All right, section 2.7, proving angle pair relationships. So first theorem to look at is the right angles congruence theorem, which states all right angles are congruent. We know all right angles are 90 degrees, so it makes sense. All right angles are congruent. It's the right angles congruence theorem. Theorem 2.4 is the congruent supplements theorem. Congruent supplements theorem. And that states if two angles are supplementary to the same angle, or two congruent angles, then they are congruent. So this example, if angle 1 and angle 2 are supplementary, and angle 3 and angle 2 are supplementary, then angles 1 and 3 are congruent. So you can see if 1 and 2 are supplementary, 3 and 2 are supplementary, then 1 and 3 have to be congruent. So if we subtracted those from 180, or subtracted angle 2 from 180, we would get that same number regardless. So that is the congruent supplements theorem. Theorem 2.5 is the congruent complements theorem. Congruent complements theorem. And that states if two angles are complementary to the same angle or to congruent angles, then they are congruent. So if we had angle 4 and angle 5, if we know they're complementary, which means they add up to 90 degrees, and we know angle 6 and angle 5 are complementary, then we know angle 4 and angle 6 are congruent. And again, so we know 4 and 5 add up to 90. So if we subtract whatever angle 5 is from 90, we find what angle 4 is. It would be a number. If we know 6 and 5 are complementary, they add up to 90. And we still subtract 5. We're going to get the same number for angle 6 that we got for angle 4. So that is the congruent complements theorem. Then we have postulate 12. This is our linear pair postulate. If two angles form a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. So angles 1 and 2 form a linear pair in this picture. So angle 1 and 2 are supplementary, and the measure of angle 1 plus the measure of angle 2 does equal 180 degrees. So if two angles form a linear pair, then they are supplementary. Theorem 2.6 is the vertical angles congruence theorem. Vertical angles are congruent. So that would be angle 1 and angle 3 are congruent. Angle 2 and angle 4 are congruent. So anytime we have lines that form an X, two lines that form an X, two lines that intersect, their opposite angles of the intersection are going to be congruent, like angles 1 and 3 and angles 2 and 4. All right, so let's write a proof. We know we have the given angle 4 is a right angle, and we can see that in the picture. Angle 4 has got the little square in the corner telling us it's a right angle. So that is the given information. Angle 4 is a right angle. Given. Then number 2, we have a blank on our statement side. But our reason is definition of a right angle. Definition of a right angle. So if I look at, where's my definition of a right angle? Definition of right angles is angles whose measure is 90 degrees. So we need to write a statement that goes with that. That would be angle 4 equals 90 degrees, or the measure of angle 4 equals 90 degrees. So we knew the definition of a right angle is the measure of an angle is 90 degrees. That is 90 degrees, so that's the definition of a right angle, so we know the measure of angle 4 equals 90 degrees. Number 3, we have angle 2 is congruent to angle 4. So if we look at angle 2 and angle 4 up on our diagram, how do we know that they are congruent? They're vertical angles. They're on opposite sides of that intersection of the two lines. Vertical angles. So then number 4, we don't know the statement, we know the reason. The reason is definition of congruent angles. Definition of congruent angles. We look back for our definition of congruent angles. Should be on this page. Definition of congruent angles is two angles who have the same measure. So that would be like, if we know angle 1 is congruent to angle 2, then we can say the measure of angle 1 equals the measure of angle 2. So back in our notes, we see that angle 2 is congruent to angle 4, so we know that the measure of angle 2 is going to equal the measure of angle 4, and that's the definition of congruent angles. The definition of congruent angles says if you know two angles are congruent, those two angles equal each other. So then number 5, the statement is the measure of angle 2 equals 90 degrees. And we've got to come up with a reason. Measure of angle 2 equals 90 degrees. How can we come to measure of angle 2 equals 90 from the information that we've already been given? Or that we've already seen, our other steps? We know the measure of angle 4 is 90 degrees. And in statement 4, we know the measure of angle 2 equals the measure of angle 4. So we could be substituting the measure of angle 4 and 90 degrees. Because of that up there. Which also means we can use so that would be the substitution property. And then we can also use the transitive property of stating, well, the measure of angle 4 equals 90 degrees, and the measure of angle 4 equals the measure of angle 2, so the measure of angle 2 also has to equal 90 degrees. So that is substitution or transitive. Substitution or transitive properties. Then that leaves us with our final statement, number 6. We have the reason, measure of angle 2 plus the measure of angle 4 equals 180 degrees, and we just need the statement. Well, underneath our given on any proof, it gives you some given information that tells you what you need to prove. We need to prove angle 2 and angle 4 are supplementary. So we can just fill that in. And we know that angle 2 and angle 4 are supplementary because angle 2 plus angle 4 equals 180 degrees. And we know when two angles add up to 180 degrees, they are supplementary. Next, we need to prove these angle pair relationships. We need to prove that two angles supplementary to the same angle are congruent. So we're trying to prove angle 1 is congruent to angle 3. We know angle 1 and angle 2 are supplements. So angle 1 and angle 2 are supplements. And 3 and 2 are supplements. So we also know that 3 and 2 are going to add up to 180. Remember, supplements are the angles that will be supplementary. So angles, let's say in angles 1 and 2 are supplementary to one another. So if we know angle 1 and 2 are supplements and 3 and 2 are supplements, that is our given information. And then if we state for number 2, the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 3 plus the measure of angle 2 equals 180. That would be the definition of supplementary angles. Remember, two angles that add together to equal 180 degrees are supplementary angles. So that's the definition of supplementary angles. Definition of supplementary angles. Then number 3, we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. So again, how can we get to that statement from our previous statements? We can get there from substitution. We can get there from the transitive property also. So substitution, if we know angle 1 and 2 added together, up on number 2, we know it's 180. We know that 180 also equals angle 3 plus angle 2. So that's the transitive property or substitution. Depends on how you're running it through your mind. Next statement, number 4, is the measure of angle 1 equals the measure of angle 3. How can we get to the measure of angle 1 equals the measure of angle 3 from what we have before it? So looking at statement 3, how can we get from statement 3 to statement 4? We can subtract measure of angle 2 on both sides. They would end up canceling out, and we'd be left with the measure of angle 1 equals the measure of angle 3. So that's just the subtraction property. And then going from the measure of angle 1 equals the measure of angle 3 to angle 1 is congruent to angle 3. That is the definition of congruent angles. If two angles equal each other, then they are congruent. So definition of congruent angles. Let me make a little change here. This should be 35 degrees. This should be what's in your notes. All right, so example number 1. We need to find the measures of angles 1, 2, and 3 when we're only given the measure of angle 4. So we know the measure of angle 4 is 35 degrees. How can we determine what the measure of the other angles are? So we need to use those properties and theorems and postulates that we just learned about to help us figure out what these other angles are. So right off the bat, you may be able to notice, all right, the easy thing to notice is vertical angles, right? If we see angle 4 and angle 2 are vertical angles, then I know the measure of angle 2 is also 35 degrees because they're equal. But then what about angles 1 and angles 3? Or angles 1 and 3? Well, if I notice that this line, that angles 3 and 4 will form a linear pair. And if they're a linear pair, then that means they're supplementary, right? So they add up to 180 degrees. So I know, say, a measure of angle 3 plus 35 degrees equals 180 degrees. So to find the measure of angle 3, all I need to do is subtract 35 degrees to the other side. Let's clean that up. So we get the measure of angle 3 equals 145 degrees. So we know the measure of angle 2 and the measure of angle 3. So we just need the measure of angle 1. So you've got two ways of doing this. Maybe you would have started with angle 1 and noticed it's a linear pair with angle 4. It's also a linear pair with angle 2. Or, now that we know what angle 3 is, they're also vertical angles. So angle 1 and angle 3 are going to be equal. So the measure of angle 1 equals 145 degrees. So we found 1, 2, and 3. And all we knew to start with was the measure of one of those angles, of angle 4. Okay, so example number 2. Same idea behind what we just did, except now we've got x's and y's, and we're dealing with some algebraic situations here. So we can set these up knowing that different angles are vertical or supplementary. So we see this angle here and this angle here. They're vertical angles, so they're going to be equal to each other. They both have an x, so that's probably the best way to solve for x. So if we just say 4x plus 7 equals 8x minus 1, and then we can solve for x. So I'll add 1 to both sides. And then subtract 4x on both sides. Then divide divide by 4 on both sides. I'm going to get x equals 2. Now, if I need to solve for y, I can see that my angle up here and my angle down here are vertical angles. So I know that they're going to equal one another. So if I have 8y plus 21 equals 10y minus 15, I just need to get y by itself. So I'm going to subtract 8y on both sides. Gives me 21 equals 2y minus 15. Then add 15 to both sides. It's going to give me 36 equals 2y. Now divide by 2. And y equals 18. So I know what x and y are. I can plug those back in and get the degree of each of those angles as well. So if I need to know the measure of angle 8x minus 1, I can plug in 2. So I'd have 8 times 2 minus 1. And then I would know, so that would just be 15. So that angle would be 15 degrees, if that were the case. And obviously it doesn't look like a 15-degree angle, but if you needed to plug numbers back in, just remember what the question is asking for. Does it want you to solve for x and y, or does it want you to give the measure of an angle? So pay attention to that. All right, and then your homework is on Schoology. Have a great day.